It's recording. All right. So 5A, there were a couple of terminologies that you had to know. There were things like expression, equation, terms, coefficient, and the last one was constant term. So there are 5 things that you had to get familiar with in exercise 5A. So what I'm writing there is the knowledge for exercise 5A. I am going to do a summary so that you can understand what is an expression, what's an equation, what is a term, what is a coefficient. Okay? So let's start off with the notes for 5B. 5B is called substitution. So once you know what an expression is, you know what an equation is, we are now going to utilize that information to then substitute values in. So let's start off. A pronumeral is a letter that represents a, anyone know? Starting with N? Number. So remember, you have done algebra in primary school. They just didn't call it algebra. When you did things like magic square plus 3 equals 4, and they said fill in the box, what would be in that box there? 1. 1 plus 3 equals 4, right? So the reason why you knew that, you didn't use any algebraic techniques, but you did know something. You knew this square box represented a number. But the problem with using geometry or shapes to represent a number, like empty triangle and empty circle, the problem is there's only so many shapes you can draw. But if you use a letter instead, we've got 26 letters in the alphabet that can do exactly the same thing, because it doesn't have to be a shape. It's just visually much more appealing if it was an empty box. But I could have replaced all of that, and I could have called it X. And that's what the only difference between year 7 high school and primary school. You had done algebra back in primary school. It's just we didn't call it that way. Yeah. So instead of magic box plus 3 equals 4, we are now using letters, and we use X plus 3 equals 4, and it means exactly the same things. It is exactly the same thing. There's no difference between this line and this line. They actually represent the same thing. So in primary school, you conditioned yourself to understand a magic box meant there's a number there. This is the same thing. X, the letter, which we call pronumeral, the pronumeral is a magic box. It's a number that we don't know. Okay? So every new letter that you use, it's a new number that you do not know. So X plus 3 means exactly the same thing. So in this case here, X equals 1. Okay? So that's what a number is. A pronumeral is. Then the next bit to understand, which was in my video, 2A. If we say 2A, this means what? You watch my video. What does 2A mean, Eknor? 2 times A. Very good. We're too lazy as mathematicians to write 2 times A. Okay, and the reason why is because you do a lot of multiplications. From primary school into high school, one of the key skills to keep up with high school mathematics is whether you know times tables. If your times tables is poor and weak, usually this is where it struggles. Okay? So we're going to start off. 2A means 2 times A, but then let's test you. What if I wrote 2ABC? What does that mean? If I wrote 2 next to an A next to a B, and B next to a C, what does that mean? Who wants to have a go? Hands up. Who wants to have a go? Carissa.
2 times A times 2 times C.
Beautiful. Every time you write a number next to a letter, it actually means times. We're just too lazy to write it. We can't be bothered writing 2 times A times B times C. One of the things you need to know is that when you do multiplication, it doesn't matter about the order. It's like saying, as an example, 1 times 2 times 3. What's the answer? What's 1 times 2 times 3? 6. 1 times 2 is 2. 2 times 3 is 6. But even if I switch the orders, if I did 3 times 1 times 2, the answer is still 6. This means when it comes to the letters, it's the same thing. It doesn't have to be in alphabetical order. Your textbooks will sometimes write them like 2BAC. But it means the same thing. It just means 2 times B times A times C. And all of it should equal to each other. Okay, so that's just the notes. So substitution, part of this exercise, you need to be able to read that 2A means 2 times A, If I gave you 2ABC, it actually means 2 times A times B times C. Okay, you break them all apart. Now let's test your understanding. We know that with numbers, if you write 3 times 3 times 3, you can write it as 3 cubed. If I write 4 times 4, you can write it as 4 squared. Then what do you think A squared would mean? What's A squared mean? Jacob? Yeah. Fill it in. A squared is A times A. The reason why I'm showing you this is because the most common mistake, students mix between 2A and A squared. They think it's the same. So when I give students A squared, they do 2 times A. This is wrong. A squared is not 2 times A. 2A is 2 times A. A squared, on the other hand, actually means A times A. And I promise you I'll get someone. Okay, so in this next term, when we do algebra, someone is going to make that exact mistake 100% every year. I have not had a year where not a single student has not made that mistake. It happens all the time. There's something about it that the 2 and the A, students just love doubling. Halving and doubling is one of the most common skills that students know, adults know, everyone knows. As soon as I put a third, 3/8, people give up. But halving, something about it. Everyone can half. It's a skill. So A squared, I'm going to catch someone next time. I'm going to remind you this as well. So A squared is not the same as 2A. They're two different things. 2A and A squared are not the same. Okay? So today's lesson, you're now trying to read, what if A was 3? Because remember, A is a pronumeral. It's a number we don't know. So when you say 2A, you're saying 2 times a number. But what if I told you A equals 3? Then in the first line, this now becomes not 2 times A anymore, but it becomes 2 times 3, because we know A is equivalent to 3. Since A equals 3, I can replace the A. That's why it's called substitution. You're replacing A, since it equals to 3, then I'm replacing that letter with an actual number. So it becomes 2 times 3, and the answer is 6. What about the second problem? If it's A squared, then A squared doesn't give me an answer unless I know what A is. But I do know what A is. A is 3. This means A times A, and that gives you 3 times 3, which gives you, what's 3 times 3? 9, very good. Hence, 2A and A squared are not the same. They're two different answers there. Okay, not the same. Not same. All right, let's recap on Monday's session if you didn't watch my video. So this is what you're doing today. So that little bit there, that's called substitution. Today's lesson is substituting the letters with a number, as long as you can read letter next to a number or anything next to each other means times. Okay, let's recap on what we did on 5A, or what I made as a video. There are 5 key words that you must familiarize yourself, because I'm going to use it a bit often, and especially in the rules to come next term, I'm going to be using these words, so you need to understand what I'm saying. What is an expression? An expression is anything without an answer. And it can have a combination of letters and numbers. So what's an example? Here's an example. This is an expression. 2A. Because 2A, I'll find another space to write this. 2A just means 2 times A. You don't get an answer from that, because I don't know what A is. If I don't know what A is, I never know what this equals to. All this means is double whatever A is. That's why it's called an expression, because you're expressing yourself. You're saying, if I knew what A was, 2A just means double it. I just don't know what A is. So this doesn't give me an answer. Versus, if I wrote 2A equals 8, this now means 2 times A, so 2 times a number, equals 8. Based on your logic, what should A be to make this true? 4, very good. So the reason why you can solve for it now is because I gave you an equal sign. This is called an equation. So here, this is an equation. You can solve it because it's an equation. Equation must have an equal sign. This one, on the other hand, that's an expression. You can't solve it because I never told you what it could equal to. So that's the difference between an equation and an expression. An equation, you should be able to tell me what the answer would end up being. An expression, you shouldn't be able to tell me what the answer should be. That's why these examples that you see here, 4a minus b, that's an expression. Over here, a squared plus b, that's an expression because you don't know what the answer is. There is no way that you could tell me what the answer is. That's called an expression. But as soon as I link them together, so say if I do something like this, a squared plus b equals 4a minus b, that is an equation, and it is possible to solve, except you guys haven't learnt the techniques to solve that. I need to give you another piece of information to do that too. But that's what you would do at year 9, year 10 level. You'll be solving equations that look like that. But at the moment, at year 8, you're not solving that. You'll be solving something like, more like 3a plus 1 equals, something like that. That's what you'll be working with. Okay, so it's a bit smaller. But as you go through the year levels, the algebra component gets more complicated. We chuck in fractions. We put in a square. We put in square roots, for example. That's what you'll be doing as you move throughout the year levels. But at the basic level, you're not doing the squares. You're just doing times, add, subtract, multiply, divide. Okay? All right. So what have I taught you just so far? I've taught you what is an expression. Expression is any combination of letters and numbers. So you can have x plus b, 5 plus c, c squared. All of that is an expression. To make it an equation, you need to have an equal signs. So it could be something like 5 plus c equals 7. Then you know what c is. C has to be 2. So that's possible to solve. What are we missing? Terms, coefficient, and constant. Let's start off here. I'm going to write an example for those who didn't watch my video. Let's write an expression. I'll write 3a plus 2b minus 5c squared plus 7. Is this an expression or an equation? Expression, because it has no equal signs. So that's an expression, collection of letters and numbers, and you can't solve it. Now, what is a term? A term, you need to understand what terms are, because when you start learning the algebraic techniques, if you don't know what a term is, you'll make mistakes. So the first thing is you have to be able to count how many terms there are in an expression. In an expression, it's made up of terms. They're separated, write a note here, it's separated by a plus or a minus sign. Okay, so that's how I taught in the video. I said terms are separated by a plus or a minus sign. Now, if you look at this expression, see how this is a 3a, then it's separated by a plus sign. In between it is a 2b, then it's separated again by a minus sign. Then I got a 5c squared, then it's separated by a plus sign. So everywhere you see a plus minus, I want to see you separate it in your mind. So how many terms are there? This is called a term. That's a term. That means 3 times a is a term. This is a term, because that means 2 times b. That's a term. This is a term. 5c squared means 5 times c times c. Because c times c is c squared, and 5 next to c squared means 5 times whatever c squared is. That's a term. The last one is also a term, but it's a special term. In my video, it's called constant term. Why is it a constant term? Because out of all these 3 terms, we don't know what c is. Could be any number, so it can change. We don't know what b is. That can change. We don't know what a is. That can change. But the only thing that doesn't change, 7. 7 will always be 7. And because it's always 7, that's why we call it a constant term. This is always consistently 7. And that will tick off all your 4 out of 5 terms there. So this is an expression. The expression is made up of 4 terms in this particular example. The signs do matter. This means this is a positive 2b. This is a negative 5c squared. And that's a positive 7. The one at the front there's no signs, but technically that's a positive 3. So hence, positive 3a. Those are each one is a term. So in exercise 5a, they will get you to read how many terms there are. Is it an expression? Is it a equation? Okay. And your last one, big word, coefficient. In the video, I tried to describe what a coefficient is. Coefficient means the number in front of, or the number multiplied to the letter. So for example, this one is 3 times a. The 3 is a coefficient. 3 is a coefficient, and the language we use is coefficient of a is 3. If I want to say the number in front of b, I would say coefficient of b is positive 2. If I want to say the number in front of c squared, I would say the coefficient of c squared is negative 5. Because the signs do matter. So that's the language. So if this is a bit confusing, watch my video for 5a to understand how to read coefficients. This one doesn't have a coefficient. This doesn't have a variable. So you have to have a variable. This one's a constant term. So only these 3 you can say coefficient. So coefficient of a is 3. Coefficient of b is positive 2. Coefficient of c squared, negative 5. That there is the summary of exercise 5a, if you haven't looked at it before. Okay? Let's test your understanding. Let's try something like this. I'm going to write one last example to see if you understand it. Say I gave you 3abc minus 2b squared plus 7. How many terms are there in this expression? 3. Very good. Separated by a plus or minus sign. So here, plus, minus, you've got 3. 1, 2, 3. So there are 3 terms. Do I have a constant term in this expression? Which one's my constant term? 7. Very good. This is my constant term. Then the last term is called coefficient. If I want to say the number 3, I would say coefficient of what? Coefficient of? Very good. Coefficient of ABC is 3. What is the coefficient of b squared? Very good. Don't say just 2, because remember the sign matters. The number in front of b squared is negative 2. So you can think of the word coefficient as the number in front of, if that helps you understand. So number in front of ABC is 3. The number in front of b squared is negative 2. Okay? That's exercise 5a. So if you want to practice 5a, those are the terms you need to know. All right, today's lesson, they're going to give you expressions and you need to substitute values. So here they told you a equals 2, b equals negative 1. Let's break this apart. Write the notes in. Let's go. What does a squared mean again? I'm testing you again now. What's a squared? Very good. Not 2 times a. This means a times a plus b. But what is a equal to? 2. It says up here. A equals 2. So this means 2 times 2 plus what's b equal to? Negative 1. Now you're going to use what you've learnt so far in semester 1. BODMAS. Which one comes first? 2 times 2. 2 times 2 is 4 plus a negative 1. So now you're going to go back to chapter 1, term 1. Use a number line if you're going to get this wrong. You're starting off at 4, so 4 is over here. I'm adding. Which direction am I going? Am I going further right or am I going further left?
Left.
Good. Overall, it's going to be left because right means positive, but then that minus means reverse it. So I go left by 1. So remember that minus sign there, the way I taught you back in term 1 was it means the opposite or reverse it. This means go to the right, and the reverse of right is left. Okay, so if you go back 1, answer is 3. Very good. So 4 plus a negative 1 should equal to 3. Check the calculators, make sure you're not getting it wrong, or check your answers to make sure you're not getting it wrong. The skill in exercise 5B is this bit. This next bit is just negative numbers. So if you struggle with negative numbers from term 1, that's why I want you to check with the calculator. Okay, so I'm not checking your integers at the moment. I'm checking if you understand substitution. Let's try the next one. 4a minus b. What does 4a mean again? What does 4a mean? 4 times a. So write it out as 4 times a, then you subtract b. But we know what a is. A is 2, so we're replacing a with a 2, and it's minusing b, which is negative 1. BODMAS again. 4 times 2, 8. Be careful here. Minusing a negative 1. You use a number line. What's 8 minus negative 1? It is add. Very good, because on the number line, 8 is over here. Minus means you go left, but because you got a negative, it means reverse. So it means you're going to the right by 1. Now 8 goes to the right by 1. Means 9. So it's the same thing as saying 8 plus 1 gives you 9. So if you're getting this bit wrong, please check your calculator, check your answers. Because that's chapter 1 stuff. The one before is today's lesson. Okay, so this is 5B. This is chapter 1. So 2 different skills. But if you didn't do well chapter 1, this is an opportunity for you to get better at chapter 1. All right, let's try the next questions. Now it has fractions in it. Same idea. Let's do it. Further down, let's try this example now. You got 2 times. Now inside the brackets, what does 3a mean? 3 times a. Minus, what does 2b mean? 2 times b. Very good. Now we do substitution. We're going to replace the numbers. A equals 4, but b equals negative 3. So all these letters there, you're going to replace it with a number now. 2 times bracket. I'm going to do the brackets a bit bigger. 3 times a, which is 4. So I'm going to use a different color so you can see. 4 minus 2 times b, which is negative 3. Up to this step, that's your skill. That's 5B skills. The next question is whether you can actually solve this bit correctly. BODMAS. BODMAS. Which one comes first? Brackets. So inside the brackets, which one do you do second now? Multiplication. So you must do 3 times the 4 and 2 times negative 3 first. Okay, that's a subtraction. So 3 times 4, what's 3 times 4? 12, good. Minus, be careful here, what's 2 times negative 3 again? Negative 6. Now you still have the brackets. Notice my layout. It's question method answer. It's vertical layout as well. Now I've got up to this step. 3 times 4 is 12. 2 times negative 3 is negative 6. Now you're going to work this bit out. What's 12? Take away a negative 6. Very good. So instead of going left, it says reverse. So you're going to the right, it means plus. 12 plus 6 is 18. So now you can say it's 2 times, and this entire thing equals to 18. So inside the brackets, it equals 18. What's double of 18? Close? 36. Very good. So you can see this bit here is chapter 1. All the way from here is chapter 1. Substitution is what we're doing today. Check your calculator, check your answers. Last example. AB over 3 plus B. Looks scary, but take your time. What does AB mean again? A times B. Very good. Divided by 3 plus B. Let's work this out. A, which is 4. B, which is, so it's times. B is negative 3. divided by 3 plus B. BODMAS, there's no brackets. So what do we do now? Which one do we do first? Which one do we do first? Very good. The numerator of this fraction, we times first, because moving from left to right, this is 4 times -3, numerator, then you divide by 3, then you add B. So the order is left to right, multiplication, division first. So here we go, 4 times -3, what is that? What's 4 times -3? -12, divided by 3, and then plus, oh sorry, B was -3, wasn't it? There we go. Plus -3. Now we can simplify this further. -12 over 3 is the same thing as saying -12 divided by 3. What does that give you? What's -12 divided by 3? -4, because 3 fits into 12 4 times. And that's a positive and a negative number, so it gives you an overall negative number. 12 divided by 3 is 4. Now we just got to work out what's -4 plus a -3. Be careful. So think about where the number line is. You're starting on the left. You're adding, then you subtract, or you're doing the reverse of adding. What's my answer? Anyone got the answer? -7 is correct. If you got -7, well done. If you didn't, can you please draw a number line to help you visualize? -4 is over here. Adding, so plus means go to the right, but then the minus means reverse. So it means go to the left now instead. Go to the left by 3. So you can see on the number line, if you keep going further left, you end up at -7. 1, 2, 3. Okay, so that's why it's -7. So that's so far pretty good. So I summarized 5A, I summarized 5B, the skills that you need. The only parts I'm worried about is your BODMAS, Chapter 1 skills. Okay, so exercise 5B gives you that ability to do so. If you want a challenge, flip over the page. There is a reasoning question. See if you can answer that. I'm going to write the solutions afterwards, but right now you can work on 5A or 5B. Or if you haven't done your reflections, can you please go up the compass, make sure you fill out your reflections. To make sure that's done. I'm pretty sure I've date stamped it for you already.
We have to do it both next terms anyway.
Which one?
Like 5A and 5B. Like we have to complete both of them.
Yep, by next term. Because there's 9 weeks next term, so next term I'm going to start 5C onwards. We have to start a bit early.
I didn't get my
Oh. Well, in that case, you can look at the screen. Are you up to 5A or 5B? 5A.
5A.
Alright, well then let's start at 5A then. Here's 5A. Is 5A for you?
It's on 3.
Oh, is it? Oh, it is too. Here's 5A, so you can see the first few questions is counting how many terms. So you can start at question 2. 2, 3 to 6, do half if you're doing the middle column. So starting at question 2. List the number of terms. In the expression, state the coefficients of A, B, and C. That's exercise 5A. 5A is relatively straightforward. It's important when you start doing the rules. Once I teach you C and D, there'll be rules. I'm going to put that in Naughty students. Well, they're writing naughty things.
No, I didn't see it. They were trying to
So that's all it is. So tomorrow's lesson will be your session. It was just 5A and B that I want to cover this week. So tomorrow's your session, it's your time. So just make sure reflections on compass, readiness for Unit 2 has been done. You can start 5A today, you can start 5B tomorrow. So that way you are up to date by the time we come back from holidays. No holiday homework. If there was homework, it's just to catch up, make sure that your chapter 1's good. Chapter 3, if you haven't finished it, make sure to do so. Upload them.
What's the individual term?
So in this one,
Yeah.
That's-
The top one.
The real top one.
yeah, this one, yeah,
The number
The
one.
number one.
this one,
The 1A.
yeah, same thing. So in this expression,
It is 3A.
3A is a term, comma,
Alright.
positive 2B is a term, comma, negative 5C is a term. So that's your individual terms.
Alright.
So this one you just list it because they want to make sure that you can see the terms. So in that expression, there should be 1, 2, 3, 4. 4 terms that you should be listing. And the signs do matter. So first one's positive 3A, second one's positive 2B, third one's negative 5C, and the last one is called a constant term, which is 2. There's a trick question there. What's the coefficient of D? Very good, because there is no D. If there's no D, then 0. And the reason why it makes sense, because if you put in a plus 0D, remember 0 next to a letter means 0 times D. And 0 times anything is 0. That's why you don't see it. That's why. So that one was trying to get you to understand. You see a letter, there's a number in front of it. What if I gave you guys this one? 2A plus B plus C. What's the coefficient of C? No. See, if it's nothing,
0.
you shouldn't see it. But I can see there's a C there. It's 1. We're just too lazy to write the 1. Technically, writing a C, clearly that's 1C there. But we just can't be bothered writing 1C because it's pretty obvious that it's 1C. It's only when there's 2 of them that we need to write a 2 so that people know that you got 2 of those C's. So if you see a C, coefficient of it is actually 1. We're just too lazy to write it. And if you don't see the letter, it means it's 0. Just like this one. There's no D, so it has to be 0. But if there is a letter, then there must be a number. It has to be 1. That's 1B, 1C, and that's 2 A's.
When we go into our readiness thing, we want to see what we answer and what we go first.
Ooh. I'm going to have to do something here. Stay here, actually. I'm going to test something.